Hello my dear students, a very good morning to everyone and welcome back to the next session of physics class. What we discussed in the previous session. In the previous session we solved some problems. I hope everybody understood. Yes. As I said in the previous session itself, today we are going to learn with another important topics. Yeah, what is that? Okay. So we are going to learn about the spherical mirrors. So without wasting our time, let us start with the spherical mirrors. Before I am just going with the spherical mirrors, and let us recall about the plane mirror. Let me take a plane mirror over here. I have taken a plane mirror vertically, and it's a silver coated, and here it is the mirror. Okay, now if I incident a beam of light rays to this mirror normally or directly, just imagine. If I incident a light ray like this, a beam of light ray, I can say it as a beam of light rays. What will happen? Definitely, it's a mirror. Definitely, it gets reflected back to where? With the same directions, it gets reflected back, right? Yeah, because the light rays which is fall onto that mirror normally. Just imagine that you just take this one into horizontal. The ray, if it is comes like this, where it reflects with the same direction right now. We have already learned regarding this. Okay, with the same directions. See, that's that. So why I am going to say this one again and again? Because we already know that. Observe here. What extra thing we have done here? We have taken the plane mirror itself, but this plane mirror itself, I just bent like this. Now you can observe the mirror. The mirror is like this. Now, again, I send or I incident a beam of light rays to this. Now what will happen? Is the same light rays will get back in the same direction? No, not at all. Because it's bent now. Okay. So now this light ray will get changes its directions. It came over here like this. And what about this one? This one also it changes its direction. And here this one it also get changes like this. And this one it also get changes like this. Observe the directions. And this is the directions which has taken place when we insert a beam of light ray to this type of a mirror. What I did simple, I just bent. Now you can ask, sir, you have done the directions for these two and these two. What about this one? It is exactly at the middle of this mirror. Right now, if I incident to the exactly middle of this mirror, the directions will take place, means the reflection will take place with the same direction. That's why I just wanted to tell this one. That's why I didn't show the directions in the beginning. Understood? Because this light ray it is exactly to the middle of this mirror. Now what happened to the light rays now? These light rays are converging. It's moving together. Right? Such a type of a mirror only we call it as concave mirror. We call it as concave mirror. And also we call by another name, it is converging mirror. Converging mirror. Because all the light rays are converging. Okay, it's moving together, moving to one point. It makes a point over here. Then what is this exact point? I'll tell you. Okay, I'll tell you. But just try to understand what type of a mirror is this. Okay, yes, this mirror we call as a concave mirror. Yes, this is we call it. Then what else? See, the same mirror. Which one? The plane mirror. This plane mirror I bent like this right now. I got it like this. Now what we are going to do is, the same plane mirror I am bending like this. Now the mirror is in this one. This is the coated surface and here is the mirror. Now say the beam of light I am going to, light rays I am going to send it to the or incident to this mirror. Now what will happen? Observe carefully. This is what exactly the midway I can say. To this mirror, I am going to draw over here. I am just extending, especially the bigger one. We call by another name. I will tell you that. What are the terms we are going to learn in this. Now the light rays will definitely get reflex. Where? It goes somewhere else here. And also it goes somewhere else. And this is also good. This one is also. What about the mirror? Same as it is, it comes in the same direction. What's happening with the beam of light rays over here? The light rays are diverging. It's moving away. It's moving in a different directions. We call it as diverging rays. Okay, so now these rays. So then what about the image? Image forms inside the mirror itself, right now? Yes. We used to draw that as a dotted line. Like this. And here is the point which makes like this itself. It will form the same point inside the mirror. It's an imaginary lens that we are writing over there. We are drawing over there. Okay? Yes, sir. So now all the light rays are diverging. So such type of a mirror only we call it as convex mirror. We call it as convex mirror, or even though we will call by another name, that is diverging. This is what the two different types of spherical mirror. Okay? Yes, I hope you understand. Okay, so now let us learn some more terms in a concave mirror as well as the convex mirror when the reflections taken place. Okay? Yes. Now here I have taken the concave mirror here. Okay? Yes. Now what I am doing is I am just drawing an exact line which is incident to the midpoint of the mirror. Exactly the midpoint of this mirror. Okay. And this point only we call it as pole. We call it as pole, and it is indicated by the letter S P. Remember. Okay, each term which I am going to say now here, that's very important terms, you must remember that. And what we are going to call this name, and this name we call it as, this line. Okay, so this line we call it as a principal axis. Principal axis. Okay, yes. Now, remember, somewhere else here, I am going to take this one as pointed C, and I am going to call this one as center of curvature. Center of curvature. Now we can ask, sir, how I can take this point as a center of curvature? How can I say that this is what exactly the point. I'll tell you how it is. Okay. So now it's a spherical mirror, right now. A spherical means I can continue with this. It becomes a sphere, spherical. It will become a sphere, right now. It's a circle. Okay, exactly the center of the circle will be the center of curvature. That's it, nothing else. Okay, the center. So while you are drawing, you can take some point as a center of curvature. It means that the center of curvature is the center of exactly the sphere. Clear? Yes, and it is indicated by the letter C. That's right. Next. Okay, so there is another point that we are going to take here. Exactly the midpoint of in between C and P, in between center of curvature and a pole, and this one will be the focus point. So how means, you know that the light rays when we incident to this mirror, it makes a point, I said right now. Yes, that point itself a focus point. Remember, for both, even for concave and a convex, I showed a point over there. Okay, that is called as a focus point. Okay, how it will be means it is exactly the midpoint of center of curvature and pole. Remember this. And now the distance between the center of curvature and the pole, center of curvature and the pole, this distance only we call it as radius of curvature. Radius of curvature. You observe, if this is a circle means definitely this is the center of that circle. So then how about this? Definitely it's a radius right now. Exactly, that is the radius of curvature. And similarly, the distance between focus and pole, we call it as focal length. Focal length, and it is indicated by the letter, that is small letter F, and this one is indicated by the letter, that is capital letter. There is a relation over here between the radius of curvature and focus. What type of a relation? Observe carefully. So from here to here it is radius of curvature. From here to here it is focal length. And this is exactly the midpoint of this one. Right now, if this is focal length means, so what about the distance from here to here? That is also same because it's a midpoint. So focal length itself from here to here. Then what is the distance between here to here then? As we know that it's a radius of curvature, how many focal lengths are there? 2 focal lengths. Then the relation between these two is radius of curvature is equals to twice the focal length. Twice the focal length. Correct? 2 times focal length. Isn't it? That is what the relation between the radius of curvature and the focal length. And also the portion, this exact portion, the reflection will take place in the mirror right now, and this is we call it as aperture. Another point, remember aperture. The exact portion, the reflection will take place in the mirror right now. That portion only we call it as aperture. These are the very important terms that you are supposed to remember when you are showing the ray diagram. Okay. Remember this. This is for concave mirror. Let's go with the next convex mirror. Now observe for the convex mirror. Now I have taken a convex mirror over here. And this point we call it as pole as usual. A beam of light rays when I incident to this convex mirror, the light rays will get diverge. Okay, so after that the images will form inside the mirror as I said. Okay, so the imaginary lines and so we draw. So that imaginary lines will make point, that is called as a focus. Okay, and this is a center of curvature, as I told you that a center of the sphere. Okay, the distance between the pole and focus is focal length, and the distance between the pole and center of curvature is radius of curvature. Just everything, almost everything is same, but all the terms will come to the in front of the mirror for concave mirror. Now every terms which we have taken to the right side means inside the mirror for convex lens. That is the difference. Other than that, everything is quite same. I hope everybody understood about these two spherical mirrors. Okay, and also relation between the radius of curvature as well as the focal length. So in the next session, let's go with the next another important topic. Until then, stay tuned, stay safe, keep on working. Thank you for watching.